So that is about double displacement. I'll give you one more example. There are many examples as such. Suppose you have AlCl3 and Na2SO4. This will give Al2SO4 whole thrice plus NaCl, and this will be a white PPT. You denote PPT by this downward arrow, which means it settles down. This will be 2. This will be, no, just a minute. This will be 2, this will be 3, and this will be 6. If you see, the balancing will be like this. Practice balancing in this, because balancing do come and sometimes they give you tricky balancing, so you need some practice in balancing the equations. Then the next type of reactions which we come to are oxidation and reduction. You might have heard this term, oxidation and reduction. What do you mean by oxidation? Oxidation is nothing but addition of oxygen. Now, addition of oxygen is just one case of oxidation. Addition of oxygen, it means just direct oxidation. But oxidation can also mean removal of hydrogen, addition of electronegative element, or removal of electrons. So there are 4 cases of oxidation. It's addition of hydrogen, addition of oxygen, removal of hydrogen, addition of electronegative element, or the removal of electrons. So for the first thing, addition of oxygen, we have one very simple example. You have copper, or they'll ask you, you have copper in a china dish and you heat it on a Bunsen burner. So what will happen? The thing is that this brown colored copper, when on reaction with oxygen, gives Cu2O, which is black in color. So the brown color will change to black, and the reaction is this, and the balancing is this. So now in this, the main thing is that in this reaction, oxygen is getting added to copper and it's forming copper oxide. So this is your oxidation. Now there is one, in removal of hydrogen, you will have copper oxide and maybe, or rather not copper oxide, you have H2O changing to H2 and O2. Now in H2O, this is changing to O2. So it's getting rid of hydrogen. So this is an oxidation reaction where hydrogen is removed from water. But you can also say that oxygen is removed from water because it's giving hydrogen also. So it's oxidation also and it's reduction also, because reduction is just opposite of this. We'll come to that later, but for the time being, hydrogen getting rid of water getting rid of hydrogen, yet changing to oxygen is the removal of hydrogen, so it's oxidation. Addition of an electronegative element can have oxygen. Oxygen itself is an electronegative element. You can have Na plus Cl2 giving NaCl. That's an oxidation. Chlorine is an electronegative element. It gets added to Na, gives NaCl. Or the removal of electrons. Removal of electrons, ionization of sodium. Na gives Na plus electron. The simple ionization. And in reduction, it's just the opposite. Addition of H2, removal of O2, addition of electropositive element, and addition of electrons. So addition of H2, you'll have copper oxide plus H2 will give Cu plus H2O. So oxygen is getting reduced because oxygen over here has hydrogen added to it. And similarly, copper oxide is also getting reduced because oxygen is getting removed from copper. Or leave that thing about oxygen. Just see, copper oxide is getting reduced to copper because it's getting rid of oxygen. In addition of hydrogen, you have H2 plus O2 giving H2O. So here oxygen is getting reduced because hydrogen is getting added to it. And addition of electropositive element, the same reaction, Na plus Cl2 giving NaCl. But in this case, chlorine is getting reduced because sodium is an electropositive element, it's getting added to chlorine to form NaCl. And addition of electrons, you have chlorine plus electron giving chlorine minus ion. Simple as that. So they might ask you the difference between oxidation and reduction. So give these 4 points in columns: addition of hydrogen, removal of hydrogen, removal of oxygen, addition of oxygen, addition of electropositive element, addition of electronegative element, addition of electrons, removal of electrons. And give an example. Now you would have noticed that oxidation and reduction cannot take place individually. They are accompanied by each other. I mean, you cannot have just oxidation. If there is something oxidized, then there also has to be something which is reduced. Like in our example, CuO plus H2 gives Cu plus H2O. This is getting reduced, but this is getting oxidized because hydrogen has got an oxygen, extra oxygen. So these type of reactions in which oxidation and reduction takes place simultaneously are called redox reactions. Basically every reaction is a redox reaction except for double displacement and neutralization. Neutralization reactions means the reaction of an acid and base to give salt and water. So these are the two exceptions. Otherwise, every reaction is a redox reaction. So if they tell you, they ask you questions to identify which compound is getting reduced, which compound is getting oxidized. So just take a random reaction